everybody, and welcome to Rocket Lasso Live. This is Season 7, Episode 4. We are already flying through the episodes. Last week was a good one. We had lots of good questions. Everybody start getting those questions together for today. I know people are just starting to get there in chat, but we need those questions if we're going to tackle anything. Let me see. Any good news? Anything to share? I mean, we got a bunch of like plug-in stuff kind of flying all over the place right now. We're trying to wrap up one. We've got two other ones that are quickly coming together, which I'm pretty excited about. I'm trying to think of if I should do a tease of them at some point. Not today, not quite at the ready point of showing it off, but that's something that I want to keep in mind. Something to note is I will not be live streaming next week. I'm actually on vacation, so no live stream next week, but the week after should be back to normal. And I definitely need to reach out and get a guest on here soon. Let's get Wimbush on here. I think he should be the first guest this season. I was talking to him at NAB, and he's talking about how we should tackle some Unreal stuff again, because we kind of, the last time we snagged him when he had just started getting into the Unreal stuff, and now he knows it way better. Let's see. That's a very, let's see, we got somebody new. Mutolib. I'm not sure if I'm pronouncing that correctly, but welcome. Thanks for coming and hanging out. Can you please show an animation setup of a handbag with a flexible movement on the handle? I mean, this is a very abstract question, but we can start with that as other people are getting those links and questions together, because it depends on what you need the bag to do specifically. Like, you would do different things for different setups. So, we can make a fully dynamic rig, but if this is supposed to be interacting with a character's hand, like, that would be a different rig. Maybe you just need some very gentle deformation, or maybe you just need the handle flopping back and forth. Is the handle made of plastic? Is the handle made of like a kind of rigid leather, or is it like a very loose like strap of leather? Like, each of these would be perhaps a completely different unrelated rig. And all of them are possible to do, but which one we'd make depends on a more specific version of the question. I'm trying to think of ways I might tackle it. If you were making a very basic, I'll wait, go ahead and type in, if you're still here, type in a more specific description of what you're thinking. But if you were doing a proper rig, meaning like you are rigging it in cinema, I might just start with a simple joint chain, which can be pretty fun. So why don't we make a arc spline here? And I'll just make this arc, and I'll jump this up to 180. So you get this full kind of 180 arc on there. And then actually, is it the way I want to do it? We might, yeah, if I set this to natural and we just increase this a little bit, you can see how we get these little subdivisions happening. And if I set that to be a kind of exact number-ish like that, if I make this editable and we go under character, there is something called convert, and under convert we can say convert spline to joints. So if I do that, we get this joint chain, and apparently, well, okay, it looks like it made as many joints as we had original points here, which was these 5. So 1, 2, 3, 4, 5. So that's actually why I need to subdivide to make more. So I will do that. I'll select all and hit US. We've subdivided a little bit more, which should give us the resolution I want approximately. So I can say sim or anime, or say character, convert, joint to splines. And now you can see I've automatically got that arc going there. It's just a quick way of making that. And then we can right click on this joint chain here. And let's go to rigging and make a IK spline. So if I say, okay, yes, here's an IK spline. It wants a little bit of information. It wants the spline we're linking to, which actually be that arc that we just made, although we might end up making a simpler one. And it wants to know what is the end of this joint chain, which will be the final joint. And that's the main bit of the rig. And then we can go down here to our handles and start adding handles in. Now, let me see if I haven't made one of these in a little bit. If we, it's an IK spline. So it needs handles, and then on the handle, we can add in some nulls. We can say create, and that makes a null. Now we do get this null, and I should be able to move this, and you see how it's wiggling that around. Now, the part I don't remember is if we add another, so now we have another, and we hit create, now we have a second null. And yeah, I think each one of these will create a handle at each point of the joints that are going along the entire chain. So I think I'd actually want to modify my spline quite a bit, where I only want like 3 points to it. I think if we have 3 points that make up the spline, and it's going to change the shape a little bit, but we can fix that. I can hit delete. So now you can see I've just got 3 joints that make this up. Let me hide the joint chain. You can see we've just got this spline. It looks like I deleted the wrong points, surprisingly. Oh no, I didn't make the wrong points. It goes to this null already existed, so it snapped to that position. That's fine. We're making this a little bit sloppy here, but the point is we can compensate. So this is the second point. So I can move this up to another position, and then we can say make the third one, because now there are 3 points that make up this joint, or this joint chain here. So I can say add and create, and that's now made of the third one. Each of these is corresponding to a point on one of the physical points that exists for the spline. So I can grab these and start wiggling them around. Now you can see that the joint chain is maintaining its length, but the first setting I'll change inside of here is going to be the type is set to fit, but I'm going to say the type is set to equal. So now if I were to stretch this joint chain here, like so, you can see that the joints are going to stretch along with it. Now these handles are giving us some arcs on here. So if I increase the arc here, increase the arc here, and increase the arc here, you can see we've got this automatic smoothing going on. And the rotation of these nulls is super important now. Essentially, the tangent is aligning along Z to wherever I rotate this null. So now if you start imagining this as the handle of a bag, if you needed to keyframe this and have a lot of control over it, I can now, just with these 3 nulls, get all this lovely bendy curving control on just this very simple joint chain. So having done that, well, first of all, it is controlling the spline. So one thing we could immediately do, instead of worrying about binding anything, is this spline is already moving for us. So I could throw that into a sweep, and inside that sweep, throw an end side. Let's increase the sides and shrink down the radius. And now, just by using these 3 nulls, and let's just call this, well, we'll just say 1, 2, 3. So I can now grab one of these and move it around. And as I move it around, we can actually get the entire rig to update. Throw this entire sweep perhaps into a subdivision surface. We have several different options we can do there, but let's say that we will put that in a subdivision surface. So that rounds out. It's getting a little bit hot doggy here. So let me turn off the start and the end caps, which will harden the edges out there. Yeah, now that should be super smooth, and we can grab this handle. We could wiggle this around, and now you can see I've got a very clean keyframeable version of this handle. Now we could run simulation and dynamics and whatever we need to on that, but that's one option. I just wanted to finish that thought where it looks like this might be more of a simulation type rig, if I am reading the question correctly. So why don't we jump on over into episode 4, save this first scene file. If everybody, we've got, I saved these scene files so that I can upload them to Patreon. So if you're supporting at the engineer tier, you get access to these. And I've been being very strict with myself, and I've been uploading all the stuff immediately after the stream. So simple. Oh, dang it. I'm totally blanking on what is the, oh, it's an IK spline. IK spline. Simple IK spline rig. I've been really strict. I've been uploading the files immediately after the stream is over. That way I actually get them out in that same day, because I've got like essentially entire seasons that have been a pain to get up there, and I've been super worried about getting them super edited down and whatnot. But it's like, you know what? These are live streams. I just have been doing edit to cut out all the early credits and then just let it go. That way it actually gets out there for everybody. Okay, so why don't we pop open the second scene file here, and actually give me 1 second. The wind blew the door open. Okay, fixed. Okay, so if we were making a dynamic object, we can do that pretty straightforward. I'm going to make a very, very simple model here. Let's assume we're going rigid body, and I guess it could be risky, but let's try and make it with a new simulation system. I'm just not as much of an expert in it, but I'm just going to not even look up reference, although that's a good idea. Let's just make a simple handbag. So I'm assuming some sort of like purse here. So let's see, how far do we even want to go? I mean, if this is The question said this was more of a rigid body. So honestly, we could leave it as simple as that if we're keeping it very simple. Obviously, there's an infinite amount of variations to a handbag. And if that's supposed to be the rigid body and the question's actually about the handle, we can keep it that simple. Um, we could put some extra subdivisions here to make sure things snap to the proper spots, but I don't remember if we need to do those subdivisions. So we won't, and we'll add them if we need to. We'll just call that one bag. And I'm thinking, let's keep it as simple as possible. Let's make a spline. We'll just add a rope simulation on here. The challenge is going to be if we can get the fall offs to be working nicely on it. So, and then I'd like to be able to try and clone them, but the cloning is a real problem with the new simulation system because you can't clone an entire rig. You have to clone a particular simulation type, which is definitely a downside to the new simulation system. So let's go and immediately add on. Actually, what I'd like to do is make sure we're sort of at a real world scale here. So if that's the bag, we'll shrink that way down and just say, okay, approximately the correct size. When you're running simulation, it's a good idea to, before you're running a simulation, before you do any rigging, make sure you're at your final proper size. So with that being the main bag, we can, I'm trying to think of how I want to subdivide it, but maybe we don't have to overthink that. I'm actually going to make another arc here. So I'm going to shrink that way down. And we'll keep it pretty simple for now. We'll make this handle. And let's just say that this is essentially what the rig is supposed to be. So let's eyeball this properly. Move it down. And I just want those to be pretty much at the edges. They don't have to be perfect. And yeah, that's all lined up. Cool. So with that in mind, let's just add a rope simulation on there. So simulation rope. This will be simulation rigid body. And let's put a little bit of a floor here. Nothing crazy. Right click and say simulation collider. And let's add in some SSAO just so we can see some collisions happening a little bit easier. And right now, actually, we need to know some thicknesses that these are all going to be. So let's immediately put that into a sweep. Immediately give it a end side. Set the radius down to 1. That's just a guess, but that's pretty dang close. So yeah, a radius of 1 seems pretty good. So in my rope simulation, we can say that the radius is 0.5. Honestly, it might be 0.5. It might be 1. I always forget if it doubles the radius for both sides or not. So we'll say 1 just to see if it explodes a little bit. We're doing simulation stuff, so it's a good idea to immediately save. Let's see. Handbag simulation. Okay. So nothing's connected, but if I hit play, let's see what we get. It's going to initialize. It falls through the ground. Now, immediately, these are some problems with the newer simulation system where you see that just fell right through the ground. They're not colliding, and yet it just went right through. So currently it's saying collide side, front, and back. I'm going to say both, even though from my perspective here, that should be fine. Let's see if it falls right through again. It does fall. The bag falls right through again. We could try adding some extra subdivisions to the overall thing. And nope, that didn't actually help. Now the bag itself might want extra subdivisions. All these triggers, like there's no settings here that are going to make this better, as far as I know. Yeah, see, this is where like we get all this amazing rope simulation, but the rigid bodies just don't behave intuitively to me. That's the bit that drives me a little bit crazy here. Yeah, Phil, I agree. Yeah, somebody's saying give it some thickness. We could give this this doesn't have thickness. I mean, we could. What is the extrude polygons? I'm not even sure what that extrude polygons means here. Show. It's not showing them, so I don't know what that means. Maybe that gives a thickness. Now, maybe what the person is saying is that if we give this thing actual thickness, it'll work better. So let's put that into a thicken and run the simulation here. That's a fine idea, making these things into volumes. That might just like it better. Nope, still falls right through. That's colliding on both sides. We can say go on the front side. Yeah, you see it even kind of hesitates there for a split second, but Let me think. That's a triangle mesh. I mean, we could do something like say it's a box collision, which it's not, but like that should, well, it's different, but it still didn't work. And these are all defaults. Yeah. Yeah, yeah, I'm always curious about this. And right here, it's auto shape, but auto probably means we can say convex hull. And let's run that again. Perhaps different again. Let's go to our simulation settings. And I hate to get stuck at this very, very, very early step, but it is this type of thing that we need to understand. I'm going to go under simulation and say enable, and um, let's activate some of the stuff. Honestly, just rigid body. Yeah, let's turn on some of these, see if it gives us any information. So these are the shapes. And yeah, you see, like, this is the box that it says it's drawing. And this is the box that it's saying it's colliding with. And yet it can pass right through. So I mean, we can crank up like the steps per frame, but like this is a box hitting a box. Now, one thought is, um, we've got all these different passes and whatnot. We did shrink the scene down, so maybe all the stuff is calibrated to be expecting a. Maybe it's all calibrated to be expecting a way larger scene, something that's 10 times the size. But like, I haven't had a great luck by grabbing the scene scale here and saying, okay, you're actually acting as if you're tinier. Although this time it did seemingly work, telling it that's a smaller scene scale. So maybe I don't know. Um, so yeah, let's say that's good enough since it's actually colliding right now. Like I don't feel like we've exhausted our knowledge of that, but that was a test. Um, Somebody's saying that we can try cranking up the geometry accuracy. I haven't honestly had that do too much. Yeah, you see, this is such a simple piece of geometry that this geometry accuracy doesn't matter. If it was a more complicated shape, it would. But this is so incredibly simple that it just didn't think that that was going to do anything. Anyway, that seems to be sort of working. So why don't we right click and add a simulation connector? So here's the we're getting back to it now. So on the rope, we're going to add this connector, and I'm going to say that I want to get live updates. And actually, immediately it did do a good job. You can see we've got these little dots. Depending on how far we zoom our camera, you can see that it might actually disappear because the geometry will block it out. But it has successfully linked those. So now the question. I got a couple questions here. Now that should be connected. So if I hit play, like to a degree, that seems kind of stuck there, and it flies away. Whee! So not great to start out. We've got stretchiness, target length is trying to maintain it. I don't care about stretchiness, max connections. That's fine. Same object. I mean, honestly, all those settings look completely fine to me. I'm going to say 0 bendiness. And that should try and maintain its shape a little bit. But the amount that we're flying around the scene here, like it seems like this connection is adding energy into the scene somehow, which isn't great. That's not helping us a lot. I mean, it's like fundamentally, it goes to we've got all these normal forces going on, and somehow these connections are adding a lot of energy into the scene, which is making it kind of fly over the place. Now we could attempt to try and counteract those forces by doing things like adding extra friction, changing the weight on things. But a lot of that is you are going to start chasing your tail around. But I suddenly just remembered something. And in my experimentation, I have found that ropes are treated disproportionately heavy. Like this rope is acting, I don't know, but just off the top of my head, it's like this rope might be acting like it's 10 times heavier than the purse. So a little tug from the rope might make the purse go flying. So what I will do is say in the rope under mass, we can set the mass to like 0.01. I'm now saying that the rope is very lightweight. I might have gone too far. I might not have gone far enough, but let's see. I'm going to play. And this time it's not flying all over the place. So this might have been that mass issue where ropes just act like they're heavy. We could have also increased the weight of the purse, but that's a relatively clean thing that we just tweaked. This wasn't just guessing numbers like we did. We did that with intention, which makes me feel a little bit better about it. Now, you can't go any stiffer than dropping your bendiness down to 0. Um, except that we can play with mix animation, but I don't know that this is going to specifically work for us. I'm curious, but if we start adding this force in, is it going to attempt to? It's essentially a wind blowing on this, saying like try and maintain your original shape. But is it trying to maintain that original shape to its very, very original position, like up here? So if we start increasing this wind, yeah, you see immediately that this is trying to get back to where it was originally, not relative to where the connections are. So this wind force isn't going to help us a lot. Now we could say follow shape, but I don't. Yeah, follow shape isn't going to do anything for us here. I'm pretty sure follow shape is taking like the deformed state and acting like that's the base shape. So that's got nothing to do with it. And I imagine using pins, yeah, you see using pins is acting the exact same way. It's forcing it up here, and it's all 100%. So it's kind of fun that the bag ends up like hanging from it. But like even if we weaken that down a bunch, the where it's like the shape is kind of pulling up, you see it just looks like makes it look like gravity's like yanking it up. So lots of limits there. Friction, radius, mass. We could do damping, which will drain a lot of energy from it, which and right now it is flopping around and jiggling a bit. So like putting a lot of damping on that will just generally be helpful. You see it calmed it down a lot. There's just a lot less energy going on there. And it just goes to like there's a lot of gravity right now. Now, to me, gravity is like a universal setting. This is like the real life value. And we made everything small, but it's like the gravity's just acting like it's too strong. So we're going to like we could start trying to weaken the gravity here, and now you can see that it's going to now behave better. But like in theory, this bag is falling a tenth the speed that we want it to. So, I'm reluctant to do that type of thing. And there's no stiffness. There is only bendiness. So we can't. Oops, I turned on airplane mode. I didn't know I had a button to turn on airplane mode. Yeah, 0 stretchiness, 0 bendiness, friction. That's fine, but none of those are going to do anything. Radius isn't going to be helping us. It seems like we do have the correct radius where you see it's sitting properly on the top. So when I guessed that 0.5, or no, we did a radius of 1. So that is a radius of 1 and it's a radius of 1. So they should match. I'll try and keep that in mind for the future. So I'm just trying to think of what options we have here. Like what would make that actually behave? Because my only thought right now, and I don't want to do it, would be counteracting forces. Essentially, we could make a wind that blows upward, and that wind could counteract the gravity just for the handle, not for the bag. We could do that. But I'm honestly getting a little bit stumped here as well. Like, yeah, these are connected to each other, but I was trying to think of ways that we could kind of stiffen up the base handle, because right now it flops down. I was trying to think of what could we say that makes these parts very rigid, and it's like I know exactly where I want to be, and the rest of them kind of follow suit. But I don't think it's going to. I don't think there's a good way of adding stiffness there, because we already saw with force and with pins just completely takes it over. Now there is these fixed points, but I'm pretty sure that's going to fix it in like universal space. So I'm also not wanting to do it, but we have to make that editable. And if I were to, and even right now, this is not a, you can see that this is got handles on it. So there's not like all these individual points. But if I did say fix that, I'm just curious to see what happens. Is that point going to be stuck in space? So if I hit play, yeah, that point is stuck in space now. I mean, it's kind of interesting because it is still physically connected, and that one point is saying you can't move, so now the whole bag is being forced to pivot. Interesting to know, but it doesn't really help us. So I'm gonna hit undo until that's not editable. Matt Dog, yes, putting less geometry in the handle would make it less floppy, but that's a I mean, is that a valid way to pursue it? Because I would say if we had like, oh, this to me, this feels like a very reasonable number of subdivisions. Um, but if we had like 10 times this, I'd say we had way too many. So, I mean, out of curiosity, we could drop in. Of course, we could like potentially run some smoothing stuff afterward. But if I did that, let's reconnect. I think I actually have to change that number to force an update. Maybe. So yeah, there's a less geometry now. So yeah, yeah, just by the nature of there being less geometry, you can see that it is bending less. But that's not necessarily the way I'd want to do that. Um, Skylar, I was kind of thinking that we could try pursuing cloth, but there are limitations to it that I don't love. And well, like more goes to does it give us anything that we're not getting now? Now, what it does give us would be potentially that we could pin more pieces, but is it any stiffer? I don't know. We'll save this where it is, and then I guess maybe we will try and do it. This shouldn't be too hard to do because we've kind of got the rig here already. So you can see I've now subdivided it, or I've now turned this into actual geometry. So I could say, get rid of the rope. The connector will move up to the sweep. We've got this end side. I'm actually going to delete out the end side and we'll make one of the new line primitives. It's actually capsule based. And if we orient this on Y, put it to the center and make it one long, we make it two long. Then you see we got this handle, and that's fine. That's what I'm going for, I suppose. So now we say that this is going to be cloth. So we say, yes, cloth now, collision on both sides. The thickness is 1.5. I'll set that back down to 1. Bendiness 0. And we'll grab this connector. And again, wiggle the value. You can see that, again, it seems to have connected properly. So if we hit play, yes, that falls. And then it kind of jiggled and it's falling over. Oh, and it's yoinking everything around. Now the handle, I don't, to me, like, I wonder how it calculates. Is it calculating volume? Because there are technically more points on that handle. There are technically more points on that handle, but do you see how it's yoinking the bag around? Like when that falls over, the whole bag shifts around. So that's making me think that this is very weighty. And kind of look at what's happening here because we got to analyze it if we're going to understand this. As it tilts over, you can see that these are stretching, and the stretching is essentially pulling the handle, but it's also equally pulling the bag. So both are being pulled around, and it's that force that's making it spin. So we did lighten up the previous one. We can lighten this one up because here's our mass. So we could say 0.1. Also, this connection stretchiness, point restriction, always draw. I thought there might have been a setting here, which there's not. I thought there might have been a setting that would say only apply the force to one object or the other. So we could just say like all the forces on the handle, not on the bag. It doesn't look like that setting exists. I think that exists in the old springs, but not on this. So we let that fall. It should weigh a lot less. And yeah, you see now it didn't fall over. Now it didn't fall over. It is a little bit more rigid. It seems to be because of the, and here's the thing. It's not that the cloth is better. It's that there's more structure to this handle. It's not just a single line because we've got all these extra pieces on there. It just gets to have more structure. So having said that, I do feel like it's okay. This is working fine. Let's continue. Let's say that there's more subdivisions. So I'll grab this arc and we'll start increasing this because I'm kind of curious. Let's go back to the original 8. So there's a lot more pieces there. Now, whenever we change the geometry, we do have to grab this and just update the number so they reconnect. And actually, that's kind of doing something I wanted to, which is we've double connected to the bottom or at the bottom one and the one above it, which should give that a little bit more structure. So if we hit play, now now it's just flopping, and just that extra geometry is suddenly making it flop over. Now, what options do we have? We have bendiness, stiffness, thickness, mass, damping, tearing, no good there. Pretty sure forces. Oh, it's mix animation. I'm pretty sure this is going to behave exactly the same way, which is going to fight the bag as well. Yeah, see, it just wants to go to the original position, not relative to where we are. So those are flopping. And do you see how we get all this? Like, even though the simulation scene, under simulation, we've set the scene scale to be a lot smaller. Do you feel like it feels like we're really, really, really tiny. It's all very twitchy feeling. And we're still running on the default. So you'd think the defaults would work pretty well. I'm going to put the scene scale back to default just out of curiosity. Now it just starts moving. Wee. If we set down to 1, I'm just curious to see what changes. Still very twitchy. That's not the biggest concern to me, but it's not a good start. Now we got this handle. We could decrease the subdivisions. I consider that a very blunt tool. It's so I'm going to increase that to connect to 2. Like, lowering the resolution is limiting us in a lot of ways, but maybe, we could start thinking of that as like a fundamental rule. Yeah, see, that's a little bit more what I want, a little bit more structure to it. But we could start considering that kind of a fundamental rule of like cloth and rope, is that the subdivisions are a rigging technique that we need to just factor in. So let's keep that in mind. I don't love the way that these are. Let's see. Yeah, see, that still manages to flop itself over. We could grab our connections here. It's 0 stretchiness and target length. Well, it's not 0, but I don't. Yeah, okay, we can lower it, but that's not going to change it. I don't want those to be able to fall over. If we lower our target length, yeah, that's just it's just squishing it down. So that's how much they can stretch. So there's actually nothing, now that I think about it, there's nothing trying to keep these to where they originally are. And remember, if we fix the points, which we can do here as well, but the fixing is almost identical. Like, it's going to prevent it from moving in world space. So we don't want to do that. Let's keep in mind that we will be able to do some soft body stuff, and soft body will start creating these interconnections between things. We can do wacky stuff like this by saying, like, we've made a bunch of connections, and all these connections are adding additional like variables on top of it, which is really powerful. This is good stuff. Right now, if we were to hit play, let's not show it's on, but I don't want to see it. Draw off. Actually, it was draw when selected. So I can just deselect. So let's see. Okay, so it's still flopping over, so ignore the connections, but it should be maintaining a lot more of a relationship between those pieces. And there's a ton of settings we can play with there. So let's keep that in mind, but we haven't gotten there yet. So a thought, this is tricky, but I mean, I'm trying to learn what we're dealing with here. So apologies for it being super meticulous. But a thought is, I want these 4 points and these 4 points to not move relative to kind of anything else. So if I were to duplicate this, make it editable, delete off everything. That's interesting. Do you see that there's 2? When I made it editable, suddenly there's 2 connectors. I'm not sure why. So if we were to select just those 2, invert, delete everything. So now I've just got these 2 polygons that are hanging out doing their own thing. Now here's the tricky parts, but if we can we connect a rigid body to a rigid body? With a connector, we can. I'm going to also turn that into a rigid body and connect. So can I rigidly lock these 2 pieces of geometry together and then give them different behaviors? So we have to use the slightly complex connector. So I'm going to make a fixed connection on this connect, and the connector wants to connect to the bag based on index. That's fine. It's a fixed connection. Auto create. So in theory, it has created it. This is here. Now let's just, I will temporarily turn that off. So those are there. Let's see if they stay stuck together. Okay, seemingly, yes. That's a good sign. Bonk. Just for clarity, let's tilt our floor over here and see if they tilt and yeah, okay. Those are now successfully a fixed connection. Good. Now, what can we do? Friction, no. Essentially, I don't want it to collide. That's the tricky part. How do we say don't collide? Deactivation, damping, no. Initial state, no. Search radius, maybe. If I say 0, well, you can't go to 0, so it's still going to be there. Hierarchy level, density. I don't think that helps. Is hollow, rotational mass. Or you could say like all this stuff is supposed to have like no effect on anything. Some of these numbers you're not allowed to go to 0. None of that matters. Unfortunately, there's no, the old simulation system in the soft bodies had a really great setting, which was like ignore self collisions and stuff like that. I essentially don't want this to be interacting at all because so now let's go to the next step, because what I want to do is our handle, I want it to connect to, right now it's other objects, but now I'm going to say actually only include this connector. Oh, wait, I forget. You have to drag in the tag, which is another thing I don't love about the system. Like that tag, this is such an, I mean, at least it says parentheses connect, but like that is a very abstract connection to me, because to me it's like I'm connecting an object to an object, but it's like no, you're actually connecting a tag to a tag. But anyway, now we're saying that this connect is connecting only to one other object, and it is specifically that connector. So you can now see that I'll make that a little smaller. So now essentially we should have a very direct, this point wants to go exactly to another point, and that other point's not allowed to move, or rather it's forced to move in parallel exactly the way the bag is moving. So that should be a way better connection now. Before, all 4 points used to connect to the edge of the bag. Now they're connecting something a little bit more custom made for its shape. So the hope here is that those connections, and actually I think we should be able to say the target length is like really small. I don't think you want to go to 0 because it can get a little twitchy. But if we say the target length is really small, those handles always really want to keep those 4 points at least of the belt, the handle here, connected. So let's just hit play. Okay, it's freaking out. Not great. Is there an order of operations that should matter here? I don't really think so. So that fixed connection's not helping us much. We did lower a bunch of these values down. So I am going to put these back to default because maybe those are multiplying on these values. So let's just hit play and see if that does anything. Actually, it did do something. So something I just did, it didn't like. So put those back to normal. Now it's working. So, but okay, cool. Yes, seemingly working. Now these are connecting, but I don't know to what degree it's a valid that's like passing through. Honestly, I'm kind of fine with it passing through. But ultimately it's like I wouldn't want to see that or render it, but I also don't want it colliding. Like right now, if this bag flipped upside down, these two things would be acting as like a collision that's happening. And really, I just want objects that are linked, that are telling the handle how it's supposed to connect, like a very kind of manual rig. But in theory, like that should be making a really solid connection. Now you can see that these handles are not flopping off to the side, and which is actually working perfectly for us. That's exactly what I want to have happen. And yeah, actually, just generically speaking, that is kind of behaving the way I want it to. It's a little rubbery, but we could add some damping onto that. So let's grab this and say Damping override. I'm really, really happy they added in this custom damping. It used to only be, you used to only get damping as a universal setting. So like right now, I don't want to slow down the bag. I want to slow down the handle. So if I hit play, you see that the handle's not flopping around all over the place. And actually, this does seem to be a global, it is dragging the overall space, because now it's like when the bag slides sideways, suddenly you see the handle is still trying to be like, no, I want to stay where I used to be. And it's yoinking the bag over. Um, so maybe a relatively light touch here goes a long way. But we have to keep in mind that that handle, well, actually, this is interesting. If we, right now, the mass is still apparently relatively high. What I'd like to do is let's hit undo a few times. What did I, nope, can't. I forget what the strength I just had was. Well, let's say 55. Let's see if it falls over again. So yeah, that current combination of this much mass and this much damping, even though I'm saying slow the handle down, the handle's like, well, I am some percentage of weight of this rig, and therefore I can like yoink the bag over. So now I'm gonna say, well, I'm gonna make you 10, like a tenth of your current weight. So if I play, now you see it didn't yank it over, but we still calmed it down. So that's actually a pretty good combination there. There are dangers with doing this type of thing, because in general, you should be leaving it kind of realistic by making this handle so light. Like, in theory, I don't know what the handle on this purse, and I want to keep going and give this some thickness and whatnot, but the handle on this purse should be accounting for what, 10% of the weight of the purse. But now I'm saying it's like 1/1000th of that on it. So if the bag were to fall sideways, it's like, well, the handle can't hold it back that much. So keep in mind that this push and pull has consequences that we're throwing at it. Now, we didn't even do any of the soft body, and it's already holding together relatively well, probably thanks to the very, very small point count that we're throwing at it. But I'm curious. I'm just going to add some bendiness on here and just see what kind of happens. So I can now fall over. We're not getting much angle on here, so let's tilt our floor a little bit more angled. Yeah, so it's enough for that to kind of fall over. Yeah, actually, you see, these are getting stuck on that real well, and we suddenly get that sharp edge on there. In theory, we could make some vertex maps to say that this early part is more rigid and it gets softer as it goes near the middle. Generally speaking, it's kind of behaving itself. We've had to fight it quite a bit. I'll lower this down. That's still quite a little bending. This goes a long way, let me tell you. Yeah, that this is finally enough where that's not just like a 90-degree turn, given the weight of that. There's other things we could do as well, like the mass. We could say that the mass, we could, like, what was I just saying? We could put a vertex weight map here in the bendiness, but we could also do the same thing on the mass. So we could say, like, down here, they weigh a lot, but up here, it doesn't weigh very much. And all those would be variables that we could control. Okay, so we've got a handle and it seems to be connected. Now, it does go to, and this goes to the mass thing I was talking about, but there's some experiments I want to do. So let's save this as next version. Simulation. I'll just save this too. That's fine. Okay, first thoughts. Let's make a cylinder, face it on Z, shrink it way down, and we're pretty much going to put that on here. And I want to see to what degree this can catch, that this can catch the handle. The handle can stop the bag from falling. I don't have high hopes for this, but let's just copy over the shape here, and we can say, I'll say triangle mesh, but let's just see what happens. Hit play. Okay, you see it's stretching. It explodes, but it's stretching there. And it's kind of like this is what I'm expecting. That's actually, it's colliding well up there. I'm fine with that. And this is what I would expect with something having so little mass. You see how it stretches, and eventually this bag is so relatively heavy that's just going to like break it, and then everything kind of explodes. I don't blame the system for that. So now we're going to make it 10 times heavier. The only thing we just changed was the mass. But now if I hit play, look at that. Now it's suddenly able to hang off of this. And that's why I'm saying changing numbers like the mass have dramatic consequences, where this seems to be doing a pretty dang good job of actually holding our bag up. Do you see how do I explain this? We built this at relatively nice looking world scale, but here's where I was saying that it feels like we're really tiny. Like this feels like, watch the way this bag is going to bounce. When I hit play, you see how it's like the way it like kind of hops around, hop, hop, hop. It's so like, yeah, it's so jittery and jerky. It feels like we're in a really, really, really tiny scene. It feels like I dropped a dice, and there's a dice like dropping, like kind of jittering on the table when you haven't dropped it very far. It doesn't feel like a larger handbag. So, and I don't have a good intuition for how to make that a little bit better. Like if we grab the scene scale and I shrink it down further, which I don't think we should, but if we do that, well, that did calm it down. Um, is that a good thing? I don't know. Let's pull the floor further away. Just see what happens. Yoink. Still, I don't blame it that handles doesn't necessarily weigh too much, but at least it's not all crazy jittery jumping all over the place. But I don't think we should have had to make the scene that tiny, even though it does look less twitchy. Let's keep that in mind. Keep that in mind as a setting we might need to go back and like fiddle with. Let's put the mass back to default on the handle. Yoink. Still very heavy. This could just be a thing. Like now I'm going to start, making the handle even more massive. And now, yeah, okay. So now you see it's almost enough to pull that off. But now you see that these connectors are saying like trying to make that connection, but they're stretching. So now we've got this separate thing of this force is trying to connect it. And right now we're saying what the target length is, and there's no additional settings to use here. Like, so it just goes to the forces here are overcoming whatever built-in value that Maxon put in to say, like, how strong can these pull on each other. So we've just hit some maximum. There's no way of increasing that directly. So the only way of improving this now would be to change global settings. So going into our simulation tab and starting to increase our substeps or increase our collisions. And let's see, smoothing iterations, straight up iterations, acceleration clamp, none of those matter. Passes, let's just see. I'm going to start experimenting. You see, those are super stretching. We're really close to that, like pulling off the ground. We could make that object lighter, keep that in mind, but let's just play with the settings right now. I'm going to increase the passes. I didn't necessarily expect the passes to help. Let's try iterations. I don't have a good intuition for iterations. As soon as I increased one, you see it actually did shrink those down a little bit. So as we increase this, you can see that actually this handle is stretching less. You can see the handle is barely stretching at all. But these are still super stretching. This iteration doesn't seem to have any effect on these handles stretching. So let's keep that in mind. So now let's try increasing our substeps. So I'm going to say jump this to 55. And that also has helped with that. But the stretchiness of those are just not improving. Extra collision or extra iterations is not improving it. We already saw extra passes is not improving it. Iterations was doing a good job with the handle, but it's not fixing that stretching. I'm out of settings. That's kind of all of them, folks. Bihavana, remember you can't put links on YouTube. You have to go over to Twitch to put the link. Oh, I see that you did go over there. I'm not sure if you put the link. Yep, you did. You remembered. Anyway, yeah, all of these cranked up settings are not improving this connector connection. And we got search radius. That's just for connections. Max connections is how many connections it can make. That's got nothing to do with it. And then we just got our stretchiness and our target length. And we already said the target length is trying to be as small as possible. That's not doing anything for us. So like there's no additional settings for us to do here. That is just acting like a limit. Now it's possible that this is multiplying on the mass of the object it's on. It's the only thing I can think of here. Now we already made it 10 times stronger, but I'm going to make it 10 times stronger again. And no, again, that did not have any effect on these connections. So even when I make it heavier. So at this point, the only thing I can think to do, and it's definitely not something I'd want to do, would be make the handbag lighter. So if we actually grab the bag and say that your density is 0.1, then now it's going to shoot up because now it's just saying, well, it weighs less. So it suddenly didn't freak out as much. But you see, even when it weighs less, we still get these, and you see them stretching to try and get where I'm telling them to go. And by the way, we still haven't figured out these being like collision objects, but I've just kind of skipped past that so we could, not be totally stumped on it. That is, we have to make this even lighter, 0.01. And at 0.01, now it's pretty dang close to connecting. But like clearly, yeah, clearly we don't want the handbag to be that light. And there it just stretches. So I don't know. Does anybody have any specific thoughts on that? We could try and treat the handbag as a soft body, like a pretty rigid soft body. I don't know if that would change much or anything. Like in theory, it's still a volume. It inherently might have a less density, but does that even help us? Phil, you can't crank the number of connections. That is the number of connections a point can have to different objects. So technically, right now, I said 3 connections, but there's actually only 1 connection. That's connecting up to 3 times within the radius, but within the radius was only a single thing. So you can't make more connections. Well, I guess the only thing we could do would be to heavily subdivide this shape, and then we could make more connections. But then once we've heavily subdivided the shape, now it would become more bendy. So those two would be fighting each other. Technically, this is essentially I start considering this bad design. Like this is not a good solution. If we were to try and increase the connections, the only place we could do it would be here. If we start subdividing these pieces, so if I say US, 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 so now that's subdivided more. Now, if I go to these connections and if I increase the radius the proper amount, oh, that's interesting. It's not quite doing what I thought. Um, I thought that that point would make. I'm going to try moving it that to there and say that connects to this. Okay, so maybe that. So now that I've subdivided that, now there are more points within range. It actually, the interesting thing there is it didn't flow from one direction to the other. Um, but now that's interesting. It's going from polygon center. It's not quite what I expected. But now you can see that, yes, now 3 connections have been made from one to the other, to the other, to the other. So now there's triple the connections. So do those work in tandem with each other? Maybe. Mm, I mean, there's triple the connections, but that still looks like it's hanging down just as far. Anyway, you're seeing a little bit of why I tend to be reluctant to jump into the new simulation system. If we're just doing some rope stuff, awesome. If we're just doing some cloth stuff, even rope connected to cloth potentially could do stuff. But once we get into this rigid body, like I'm not able to make it behave the way I want it to. Even when we just started doing we were trying to drop a real world size box onto a normal ground, it just kept on wanting to pass through. And yeah, these extra connections, I mean, just for the fun of it, why don't we grab this and increase the radius even further? So now you can see each of these points is connecting over onto the cloth, so that's making a ton of them. And even here we're hitting, actually, I don't think this connection count even makes a difference here. But now we got like a ton of connections. And I doesn't look like it's still hanging just as far down. Yeah, I don't want to spend a bunch of time banging our head against something. I was kind of willing to explore this particular pathway as long as we were learning things about the simulation system. And we did do a bunch of like kind of clever workarounds here. Like we were, like connected one object to another object, and then we're able to make the connections there, changing this over to be cloth instead of rope. Gave us a lot more control. And we haven't messed with too many of the settings. We're still in vanilla global settings, where we're still in the defaults, which I always, that's a plus. I don't want to crank the settings any higher than I have to. But honestly, we haven't even gotten to the parts that I thought would be somewhat challenging, which would be like, what if you wanted to clone this, which I always think is interesting. Like, what if I wanted to clone this bag a bunch of times? But the way the new simulation system is set up, I couldn't just put all the stuff in a null and clone it. In fact, I'll show you. If I make a null and we grab all the parts that matter, which is not that, but let's grab the handle, the bag, and this funky connector thing we had to make, and drop that all inside a null. If we put that into a cloner, and let's set that to 50 by 50 by 50, that's fine. If I hit play, you can see that the simulation is going to the simulation is just running on the object. So we'd actually have to, like, this is the most obnoxious workflow, which yeah, where we'd actually have to make a cloner with just this connector and then move the simulation tag up to the cloner level. And so to make this clone series of clones of bags, you'd have to make 3 different cloners, one with just handles, one with just bags, one with this funky connector thing, and then run all this simulation stuff on the cloner level. And then every time we change a variable in the cloner, we'd have to go back and reset all the connections. And like, obviously that's a very obtuse workflow to me. Like the old simulation system, you could have just thrown all this into a null, dropped in the cloner, it would work. Yeah. So yeah, the Rigidbodies not cooperating. Now, I'm trying to think of Dean. That's a crazy idea. Dean's suggesting that we act as if this is a single piece of geometry. It's all a single soft body, and we just make different parts of it rigid. Like with vertex maps, in theory, you could do all that. But well, you're still going to be limited to the bendiness. But I like the idea. It's a weird fun idea. So I'm down to give it a try. So we're gonna say that one kind of went as far as we can. Not super happy with the end result, but now what's the best way to do this? I guess I can just modify this geometry. It's gonna be a little bit funky. And honestly, let's just start. I'm gonna delete out all those simulation tags. We'll bring that back. We don't need that anymore. And let's just make that editable. Go away and physically connect these. So connect objects and delete. ME for weld. And I'm going to say weld that to there, weld that to there, weld that to there, weld that to there. Okay, so that's the simplest way we could connect all of that. So now we've got this single piece of geometry being the bag. Let's say simulation cloth. And let's say 0 bendiness. Everything's default here. So I'm just curious, all default. I think everything's default at this point. Let's just see what happens if we run that. Boing, 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 boing. Okay, like not horrible out of the gate. Because this bag is so low poly, in theory, we can trust it to act kind of rigid. And then now we could start making some vertex maps, say that loop. Okay, the loop selection, interestingly, didn't continue through, but I guess that's to our benefit there. Hold down shift. Actually, I'm going to deselect. We're going to act like this little transition is rigid. Hold down shift as I click 2 points, and now we've got those points selected. Right click, other tags, vertex map, and let's say apply selected, and now that's saying 100%, this is saying 0%. We might invert that, but for now, I'm going to say this whole bag is 5 bendy, and if we hit play, okay, given the current setup, okay, maybe bendy, actually it's kind of interesting. Isn't that, I don't quite understand why the curve is behaving the way it does there. Like that should be getting pulled taut. So are these polygons acting like they weigh more? Like this, I'm still, I don't know for a fact, but it's like, is it calculating volumes? Because it doesn't feel like this is calculating like a volume. This bag no part of this bag feels any heavier than any other part. This feels like it's, filled. I can't even think of a material. This whole thing's made of balsa wood and it's full of air. Um, feels like this weighs nothing. So, is cinema calculating mass by volume? Doesn't feel like it. Is it calculating mass by polygon area? Honestly, it doesn't feel like that. What this feels like to me is it's calculating mass based on just how many points there are. So there's more points up here. So like, does that weigh more? Um, like maybe. I guess I want to find out. I want to find out if, let's see if we can gain some information along those lines. So I'm going to grab this edge and say D. Those must be welded together. I'm not quite sure why I extruded 2 out, but let's just delete that 1. And I'm going to stretch this way over. And let's select that, hit MF, apply, increase that a bunch of times. So essentially I'm putting this little extra leather strap over there. Keep in mind, everything is uniform right now. But essentially all I've done is put a bunch of points on that side. Because obviously it's infinitely thin, so it doesn't have any volume. And I just want to see, does that make the bag tilt over? Oh, it way makes the bag tilt over. In fact, well, actually, no. That might not be true, because the way this model is now, it's acting like that's not connected anymore, because that shouldn't have been, there's no tearing here. So how did that just tear off? That's bizarre. Maybe the soft body doesn't know how to handle this complex pole. So yeah, let's keep that in mind. And remember I said it was kind of odd that there's like that double extrude. Anyway, I'm gonna select all, right click, and let's do an optimize. And yeah, I'm just gonna increase this just to be like, okay, those are all within range, so everything should have been welded together. But I don't think that's gonna change. Oh, it did change. Okay. Okay, well, now we're to where I was trying to do the experiment. And look, that still feels like that little extra strap. It's really heavy. It's really pulling the bag down there. So this is making me think that the weight is getting applied by like just sheer point count, which is kind of crazy. That's very good information to know, though. So what that means is this handle might weigh 30 times more than the bag right now. And that would explain, and all of this I derived from the bowing, um, from the bowing of this handle. So if we get rid of that and we do this, the only thing that would explain this curvature that we're seeing is that this handle weighs so much that's weighing more than the bag. It's actually pulling the bag up a little bit so that it itself can get pulled down. So anyway, we know that now. Okay, now this weight map. Can we? This is a little unfortunate because we can drag this weight map in here. And yeah, we got this minimum map. I don't have a good intuition for this. I don't know if we need to invert it. This minimum mapping, I think, means that we could say it's actually not 0. It goes down to 1%, which is good. That's a really handy handle to have. But here's the bad thing is, if we were to modify the geometry, that would mean we need to modify our vertex map to be different weights just based on like how many points there are. But let's just see what we got. If I hit play, okay, it seems backwards. It seems like we have to invert the vertex map because right now it feels like the handle's even heavier and the bag is even lighter, is what it feels like to me. We should be able to just say remap, linear, flip horizontal, apply all, and that was a way of mirroring the values internally there. Okay, now, in theory, we're saying that the points of this handle, even though there's like 30 of them, should be weighing only 1% of what the bag does. So keep in mind, they're already times 30, but now they're 1% of times 30. So let's hit play. There we go. That's looking a little bit better. So now this hand, it's a single piece of geometry. Now we've got a nice, like we've got a handle that weighs a lot less. And keep in mind, the only thing we just changed was the mass. We've now said that the handle weighs less. Let's get rid of all this bendiness. I'm just curious. Yeah, I don't think that bendiness is having too much of an effect. Now we are getting, Yeah, actually, Dean, that could be a good question. That because we're feeding it an object that has areas that have no thickness, they're not a volume. Maybe things would calculate a volume, but because parts of this don't have a volume, none of it gets a volume. Let's keep that in mind. But if we gave that handle thickness, like we essentially giving the handle thickness, I think would negate a lot of what I'm trying to do here. Um, boing, boing, boing. But anyway, well, look, this is, I mean, well, here's a good thing is that we do have a rig right now that is clean. Like all we've done is put a vertex map on to say certain parts are weaker, and then we get the soft body. It seems to be running pretty cleanly. Like this springiness, I'm quite happy with this type of springiness here. We could potentially put some damping or something in here to slow it down, but I'm actually, if we were able to get to this point quickly, I would have been quite happy with it. Let's see what happens if we drop the bag onto the ground. Boing. Yeah. So now we get this handle, and it's actually, like intuitively, like I kind of like what that handle is doing right now. Like it's boing, 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 flopping around. It's kind of springy. We could calm that down a little bit, but it seems like it has to go wherever the rest of the bag goes. Like the weights feel a little bit better. This whole thing feels a lot nicer, but it's all one object. So all those fancy, crazy connection things that we have tools for, like they're not doing anything for us, unfortunately. But yeah, now we got this nice handbag. From here, I'm trying to think of what are things we could actually do. Because essentially we want to make a usable rig here. This was the original question, and honestly, we are learning some knowledge here that would be useful things for us to be able to apply to other places or have different knowledge of. Bag simulation, single object. So if tricky, like, so I'm going to try and modify some things here. What happens if I put a single stripe? Yeah, the way that selection happens is really odd. I just hit UB, which is a ring selection, but you see my ring selection terminates here, but you would think it would continue around, but still treating these as separate things. So I'm not quite sure. I'm not sure what that key's off of now that I think about it. But anyway, now I've got all those. MF apply 1. Now I've cut a stripe down the entire thing. Let's double check our vertex map. Okay, those subdivide, it got applied correctly because those were essentially getting the values applied from their neighbors that they were derived from. So that worked really nice. If we hit play, I don't think it's going to be super different, but it'll be a little different. But yeah, okay, that's fine. This is not going so far that is causing us any real trouble. Boing. And actually something else. As we go through here and try and push the rig and see how far we can push this type of thing, I am curious if we can put this into a cloner and go 55, 55. And I don't want to mess with that too much. I'll just let that one intersect. Now, if we have play right now, it's not going to work because simulation tags can't be on children. But if I just move that singular tag up here, will it work? Will the vertex map propagate each clone up to that tag? I actually have decent hopes that it will. So, yep. Okay, yeah. See, that worked just fine. Relatively easy to clone, but only because it's a single model. We still had to move our tag up a layer. But I just want to see if that worked. Okay. Now that worked, there's no vanilla way I can think to do this, but I just want to throw it out there and I don't even know if this will work, but I'm going to make a selection here, and we're going to try and use the Rocket Lasso plugin mesh to spline and see if we can actually convert this to a spline live. There might be a frame of lag, which would be unfortunate just because simulation usually is the very last thing to calculate. But anyway, if I make that and we say select store selection, and let's just call this handle. If I make a Rocket Lasso mesh to spline, and I will remote link into it, so I'll say link to the bag, that should be creating, here's a spline version of it, which is what the tool does. But I can say actually restrict to a selection, and the selection will be based off this selection. And now you see I've actually just got the end result of that line. So now the question is, if I hit play, is that going to move? And yes, it does move. So our tool is properly refreshing to at least see that, yes, indeed, that's animated. But hey, that's a Rocket Lasso tool for you. But the question is, yeah, that's maybe this might be one of those things where it gives you, it looks like it's lagging a frame in the viewport, but maybe it is actually correct in the render. So now that that's happening, if I can feed the rocket lasso mesh to spline into a sweep, feed in this end side to a radius of 1, a radius of, let's say, 0.5, a couple extra sides. Now I've got this separate handle that I've made. So if I hit play now, and you see if I do that, it looks like it did an update. But as soon as I move my mouse over the viewport, which is a good indicator that it will refresh, it actually does snap to it. So is that actually a separate piece of geometry now? So we're able to do all the calculations from one thing and then turn into a parametric object afterward. And then I'm trying to think of any way I could hide this geometry, but I don't think I can think of ways. This is a sloppy way. I don't like it. But if we create another selection, store that, we'll call this cloth handle. If I wanted to do it here in the viewport, you could obviously apply a transparent material on there and say, oh, you're transparent and you don't render. So let me show you what I'm thinking. I just want to delete those polygons out. So if we make a parametric capsule-based delete, I can drop this on there and you see those will actually just disappear. But that's disappearing before the simulation. So what I'm going to do is put this into a connect object, don't weld, but now simulation is running on the bag, and then I'm going to say delete. It's running on the bag, and then it gets connected, and then I'm saying delete the polygons after the simulation. So now you can see I don't see them, but with any luck, as this falls, you see that it is still there. Keep in mind the connect object is not a fast calculation here. Like we're actually making this cost a lot more in frames than we normally would be, but it's such a simple piece of geometry that's going to be essentially not bothering us at all. And actually, this connect object, seemingly this connect object is forcing a good refresh because now the handle that we applied is properly there. Boing. And there we go. That's kind of a rig that's kind of working. I feel like I'm learning things, which is the only reason we spent like over an hour on the singular question. Like I know, generally speaking, people want to be jumping to a bunch of different questions. I do feel like there's a lot more to pursue here. There's some interesting things that we're exploring, having this be a single piece of geometry. A thing I would be curious to do is kind of learn if putting volume, like making everything here a proper watertight volume, would give us more control and the weights would have been applied a little bit better. We could be tinkering around here, putting more custom vertex map weights to make this top part be bendier. Actually, even here, we could just add some bendiness in. And this bottom part of the bag has enough structure where I don't think we really feel the bendiness. So yeah, man, look, a little teeny weeny little bendiness goes a super long way. So now it's only 1. And yeah, even there you can see how sharp that is. So let's try like 0.25. Yeah, so something like that is like a little bit bendy now, so those handles can actually go. But thanks to the way they're forced to connect, you can see that this connection here is still perfectly on the edge. And even if it stretches, then the rocket mesh spline is going to just stretch appropriately and also continue to match it. So we're not, this rig will not give us those connector problems. If we bring the cylinder back and we split the stretch, boing, well, it escaped just because of the weight of the bag, but you can see that everything's still perfectly connected here. We could lower the overall weight, which might stop that from stretching. But to me, just this is the thickness of the handle and whatnot. So this is just a question of like adding in some extra. I guess we were running some extra iterations there. Curious, but yeah, that's super going to snap. So extra sub steps or extra iterations here are going to be the solution to stop that, because it's just there's too much geometry trying to pull through something else. But you can see that that's working pretty well. That's working surprisingly well. So yeah, good call there, Dean, on attempting to do this as a single piece of geometry, which is a good, just like, oh, let's simplify. Having said that, like you see a lot of limitations to what we're doing here. Now, having said that, we're tricking it to run as a single object. We could do things where we could maybe constrain an object onto being the bag. So the bag, we're not limited to this low poly simulation of the bag. We'd have a high poly version that's snapping to those correct locations. These are things that potentially could be done. to improve this overall situation. I'm trying to think of where to go. Should we move on to, like I said, I could explore this more and figure out like volume things. But we could probably move on to more questions. I'm thinking we might move to a different question because we've spent an hour and 15 minutes on this one already. I'll save this one. Mesh to spline. I always label if we're using a plugin just so people know that that file will be limited in some way. Yeah, tricky. Let's see. So, the question from YouTube. Thanks very much for the question, and welcome to the stream for a first-time person joining us. Bihavna had a question a little bit earlier. How would you use the new particle system to create this kind of effect? Don't focus on the physical rock, rather, how to get particles to subtly interact with the collision object in the scene. Let's switch on over to the screen here. Let's check out the link. Mute. So this is from 6 and 5. Well, is it from 6 and 5? You got to be careful because this could be a direct artist. Yeah, this seems to be the artist. 6 and 5. So, okay. Now, as we haven't pointed out, it's not so much like we're not worried about the rock specifically. It's that we've got this very organic feeling, natural feeling flow. Do we? I'm investigating these. There's interesting things happening because it's like we got these streaks. Are those streaks like tracers behind a particle, or those could be bits of grass at the seabed that are stuck in position? Like I don't feel like those bits of. I don't feel like these bits of streak. Oh, wait, no, those did seem to be moving over there. Yeah, they do seem to be moving. Okay. But I think more of the question is how these have this really nice flow and they're flowing around the rock. This definitely feels a little bit like a liquid sim to me. But I can think of. I think I can think of. Some ways we might be able to tackle some things in the vein of this. So let's hop back on over to this computer and open a new file. And let's begin. We're going to need our particle, my custom particle layout. And we're going to make a basic emitter. And I think it's a good idea for us to stay in a two-dimensional world. So let's shrink that down. If we hit play, yeah, we're going to get our stream of particles going. Well, let's crank up our frame count, which didn't go. Okay, way more particle. Oh, yeah, way longer time. We got this particle stream, and I want them to live for about 200 frames. So properties, limit the life to about 200 frames. So a bunch of things. First of all, let's immediately limit these to be on this plane. So the position y is going to be set to a constant. So there, it can get no height here, okay? Now, we need to constrain them. So we're going to make a box. Yeah, I think we'll just try a collider. They did fix a major bug that was with the particle collisions, which is huge for us because I feel like literally every stream we had last season was asking to do some kind of crazy particle collision thing, and it never worked. And now it does, which is exciting. Simulation collider. Right click. Also, render tag display. Use lines. So now I just see this box as a reference. Actually, we'll probably make this only like 10 tall, just so those should still be trapped. But yeah, but we can tell where they are. Now, why am I doing that? Well, because, well, first of all, let's see if we're colliding. So we need to make a collider, which, oh, I guess we could use deflectors. I think deflectors work, but let's play with a collision. And actually, why don't we save this immediately? Particle flow drift. Let's see, for you on the stream, I'm going to increase the particle size. So those dots will be larger. And then we need a collide. We'll say that these are going to collide. I'm not sure which order we're going to want these, but let's put these in. Collide. Yeah, they are going to physically collide. We can't tell if they're colliding yet. So let's make a turbulence. And this turbulence is going to make everything drift. And it is not successfully colliding yet because you see these are escaping directly under this collide. Collide. Oh, let's grab this and say collide to the back side of it. Promising. Yep. Okay. Look, now those are bouncing off there. And with any luck, if we view this from the side, we're still two-dimensional. So now we're in this world, two-dimensional, and they're bouncing around. Cool. Okay, no turbulence. Now, here's where things will get interesting. We want some flocking behavior. You know, I love some flocking. So we're going to put this before the collide. And what do we want? I don't think we don't need to worry about cohesion. Maybe we will, but I mostly want to worry about the separation strength. So we're going to increase the separation strength. And essentially I need to get this to the point where we can, okay, there we go. You see, like, this is probably too high, but now you can see it's high enough that all these particles are pushing against each other. They're trying to fill the space. Let's see, they're living long enough that they're hitting the end. So I'll make that a little bit, make that a little bit longer. So these are pushing apart from each other. And let's do some other things. I will make a wind. Let's make a wind, and that wind is blowing it. And why don't we, I'm going to tell the emitter, actually, they are emitting at a certain speed right now. I'm going to say that's fine. But I'm also going to add in, let's see, that can be first. Oop, wrong thing. The wind can be first. And then I want some friction. Friction, friction, friction. Interesting. Is the wind blowing? What's going on here? Turn off that friction. It's blowing forward. I'm just curious why they started slowing down so much. Anyway, I'm going to make this friction, and the friction is constantly slowing everything down, and then the wind is going to tell it to keep on moving forward. And this is just making it so that as the particles are pushing apart from each other, that they're not like gaining a ton of energy and flying all over the place. Now we need enough. I might slow the whole system down a little bit. So the wind, say 55, and the friction should slow us down quite a bit. Yeah, okay, that's slowing us down quite a bit. You see everything's piling up against each other, and we're kind of filling the space. We do have to kind of eyeball how many particles we're throwing at it, because if we throw too few, there's going to be gaps. If we throw too many, there's going to be too many, and they're going to be fighting against each other. But now those are all, I think we got all the variables in place pretty well here. So now we've got all these points that want to be a certain distance from each other. So let's see, let's make them live a little bit longer just because of our current speed. Particles 333. We could even potentially turn on some turbulence here. I don't have a good sense of scale, so I'll make a figure. Okay, we're pretty normal here. So if I make the turbulence have some scale here, then you can see that we're going to get this kind of like large shape kind of blowing the stuff all over the place. Let's say it's a little bit smaller than that. A little strength is going a long way here. So we're going to say just like 1, just get a little something bopping around there. Give it a little time to settle. And yeah, so this wind's going to blow one way, it's going to blow the other, just letting it drift around. Anyway, let's build our rock, and our rock is going to be a cylinder. Scoot this forward like so. Shrink it down. Shrink it down. Okay, so that's going to be the rock. And now I think we've got all the ingredients in place. All this stuff wants to do a particular type of behavior. All these particles are going forward. You see they're all pushing apart from each other, so they want to maintain a certain distance, but they all want to flow forward, much like that water effect was. So give that a save. Copy this collider onto there. And this one, I'm going to say collide with the front, not the back. I don't know if friction's a thing, so I'm just going to grab both of those and say no friction. Don't worry about friction. Okay, let's hit play and see what we get. So these are all flowing forward. Now these are going to start encountering that, so it should just bounce off of it or just strike it, and you see it strikes. And then now everything is forced to flow to the sides, and as they get around the side and all these points get there, they want to push back apart from each other, and as they push apart from each other, they're going to start filling in the space. It's that pushing apart from each other that's actually enabling them to refill this space. And this is now creating like a wind shadow. Like the wind is blowing in a particular direction, and because this is blocking everything, there's a shadow behind it. So the strength of them pushing apart from each other is how quick these are going to fill this gap back in again. And actually, where you get kind of a fun slowing down effect, and I didn't even anticipate this specifically. I'll zoom out a little bit so the particles get to be a good scale, because these stay the same size no matter how zoomed in or out you are. So if I zoom out here, you really see them nice and beefy. The very first particles that strike this cylinder are going to just strike it at full speed. But subsequent points are actually going to decelerate because they're getting close to it, and then that push apart, this flocking separation strength, as they enter this radius, which is a radius of 10, they're like, oh, I'm getting near particles that aren't moving, so I'm going to slow down to try and avoid them. So it's actually naturally creating this friction, this slowdown. Separately, I thought maybe I'd make a little friction or some sort of force that pushes away from the cylinder, but honestly, I don't even feel like that's necessary. It's just naturally doing it. So what's cool is we've now built a behavior in here, so we are free to just make copies of this and reshape the entire thing, or make as many of these as we like. So I can make a second rock here, make it a little bit smaller, and I'll scoot this one here. And I didn't move it up, didn't I? It looks like they're ignoring that until I reset the simulation, which is, I guess, not surprising. All the particles get initialized at a certain point. So we'll just do stuff like that. So if we just restart, particles flow. Boing, boing, boing. You see the first one's hit it hard, but then all the subsequent ones are going to slow down. And now these should exist. So boom, boom, boom. Those have to flow around themselves. So we get a particle shadow, particle shadow, particle shadow. So pretty fun. I mean, it's a really great question. And like now that collisions are working, look at how quickly and easily we were able to do that. So in all the things we were just kind of griping about with the simulation, the rigid body simulation system not working for us, the particles are behaving exactly the way I wanted them to. This is precisely what I wanted it to do. Let's make those particles live longer still. So basic emitter, 555, reset again. Let's just see how this goes. Yeah, particle questions have been working great. Jay, I thought the wind was blowing backwards as well, but no, it's forward. Optical illusion. They face forward on Z, and you can see actually the arrow pointing forward. But I also too thought it was flowing the wrong way. Yeah, they're backing up real nice here, flowing around, colliding here, flowing around, getting really choked up here. and then but eventually they get to fling out, and then given a little bit of time, they will spread back out again. So yeah, let's grab that particle wind, make a tracer object, and set that to from end of 22 maybe. Nope, don't need that much. Yeah, I guess the particles are moving briskly, so we honestly don't need much. Something like that. Go figure. Look how I don't understand why this computer does this. Do you see how it was suddenly like I'm going to go super duper fast, and it's like nope, I'm going to go slow now. Someone with the GPU is like occasionally like I'm going to go super fast, so you just see like this incredible speed, and then sometimes it's like I'm not going to. No idea what causes it. But yeah, get this lovely flow. You see the turbulence is actually helping us a little bit with this like natural kind of drifting around, and yeah, just a nice emergent behavior. You get a lot of emergent behavior as soon as you start using things like flock. Yeah, and these lovely shadows here. That's interesting. Even here, there's like some personality to the direction, just because there's fewer particles here on the left side, but they almost seem to be able to get in there. Yeah, they're getting in through there faster, so it's kind of forcing everything a little bit to the right. So yeah, again, a little bit more emergent behavior. You see the clearest example here, this nice, clean kind of teardrop shape on that one, because that one's dead center. The other ones get a little bit more of a dynamic behavior. Ooh, particle escape through. Yeah, so yeah, quite pleased with that one. Hey, Wimbush is here. What's going on, man? Okay, yep, I did add a tracer. I didn't even read that in your comments, but like you gotta add a tracer. Um, so yeah. I'm trying to think of what else to do here, but it works so perfectly. I'm not sure what else to do. Now, keep in mind, I did a lot of things here to keep it two dimensional to give us control, but this didn't. This does not technically have to be two dimensional. We would need to throw a lot more particles at it, but just to show you, I'll give this a save because it's pretty much exactly what I was trying to make. But if I turn off the tracer, let's bring the particles visually back. And now I'm going to delete out this math, and the turbulence should automatically give it some Y. It's going to move up and down on Y thanks to the turbulence. So now it can fill up this entire box because, keep in mind we're colliding top and bottom. I will grab all of these and just make them a hair taller. Just make sure that they're still trapped in the box or fully covering the box. But now, as these go, they're actually going to be able to fill up the entire volume a little bit more like a liquid. Now, obviously, Maxon showed off a technology preview of the liquids, but now this will fill the entire volume, which is going to probably call for more particles. But this is just to show that we're not actually limited to that two-dimensional thing. These are now three-dimensional. They're in a relatively skinny three-dimensional cage here, but you can see, I think it should behave like identically here. We got particles. A lot of them are kind of pushing each other top to bottom just based on the radius, but um, let's see. Yep, same range shadow. I'm actually surprised at how much it's still able to fill this volume. Very interesting. It's interesting how the top and the bottom are mirroring each other, probably because the forces are forcing them to mirror. Oh, even look at this kind of like turbulent churn that we're getting there. That's kind of fun. I wonder if we are getting some slightly liquid-like emergent properties. Just for fun, let's make these taller still, maybe even 30. I don't want to go too far because we'll need more particles. And we'll also make the box 30. Let's reset. And I think we just need more particles. So I will say emission, dare I double? Let's do it. So more particles, same thing should be happening. Not quite enough to fill it up, so I might need to emit more. But as they slow down, actually, yeah, as they slow down, I think they start pushing each other more, and I actually feel like they're moving a little. Maybe it's just going slower because we're losing frame rate because there's so many particles. But yeah, now you're properly starting to get like this entire volume. Now, if we were to do other things like add gravity in here, so there's gravity pulling down on these, then in theory, this whole thing could be like three-dimensional, where we could actually make like a waterfall where these would actually be trapped. Like essentially, we put no top on this box, and gravity would be keeping them down. They could like splash and be three-dimensional, fall down different pieces of geometry. I don't think it's specifically worth putting together, but you'll see if we view this from the top, maybe a little less so, because I'm not sure, maybe it's just there's a lot more forces. I think we need to increase the wind, but you do see that we kind of get this little bit of churn and shadow behind it. But I think there's just a little bit less forward momentum right now. And it could just be the all this flocking behavior is sort of making that happen. If I grab the wind and we double the speed of the wind, like I think the more wind, yeah, the more prominent these shadows will be. And you definitely see, like, from this distance, look how dense the particles get here as they're choking up. We hit the frame limit there. So yeah, a little bit more wind, but as they hit these choke points, there's going to get, it's increasing this density. That increased density is pushing the other particles around. And then as they are crammed in and too dense, they push apart from each other and fill the void back in again. Visually, this is always something I like doing. If you want to make something look instantly better, we can start giving this some particle color variation. And my favorite way of doing that is let's give it a noise-based color. Let's go kind of crazy here. Actually, I grabbed my neon colors here. I might double the knots. Just double those knots, maybe even double twice. And it's noise-based. So if we say the noise is animated, and let's increase our scale. Nope. Bigger. Way bigger. Let's see. I'm going to get... Wow. Okay. Animation speed 0.2. Okay. This is way bigger than I thought it would be. Okay. Now we're getting there. So now let's make it about half that amount. Yeah. Okay. So now we got that. So now you can see I'm slowly shifting color by animating it. We have a very large cloud. So now we're able to spit out all these different colors, and based on actually X, Y, Z, if we shrink this one down, yeah, I wanted to get a couple little stripes in there. So I just squished the noise down in this orientation. So you kind of get multiple colors coming out. But yeah, based on these colors, now we just kind of feel the flow a little bit more as they go and as they churn. Actually, what's kind of fun is we should be able to see them churning around a little bit. We get all this uniformity in the beginning, but as they start smashing, we get some, but by the time they collided, we go through this choke point, you see that the colors are becoming just very intermingled. So, again, kind of some fluid dynamic type stuff here with lovely rain shadows. So yeah, I dig it, and I'm very pleased with that one. Thanks for the question. That was a fun one to try and tackle. We can move on to a completely different question, or if anybody has any follow-ups to this one, we could, try and make the rig more elaborate if we can think of additional things to do with it. Let's see. Yep, tracer. Yep. I don't know Helmholtz instabilities, so sorry, I can't reference that. Demis asking or unfair. No, last two don't seem to be colliding. Oh yeah, when I refresh, yeah. The simulation, essentially the why it wasn't colliding with the shapes as I copied them and moved them in is the particle simulation stuff is its own engine. There's like a completely separate engine. It's inside of Cinema, but you can think of it like a completely separate engine inside of Cinema. And it's taking it's taking the scene and it's sending it over to this other engine. Kind of think of it like when you send your scene file to Octane to render. It's kind of sending the whole thing over. So it's doing the same thing here. So when I create additional geometry, it's not sending over the entire scene every frame. It's sending over the scene initially, and then any new things you make, it doesn't even know it's there until you go back to frame 0, and it, how tons of things in Cinema rebuild on frame 0. So that's just the case there. Let me show you something that's kind of cool. I don't know how well it will go, and it could mess the colors up, but kind of a technique I've been enjoying. Let me think of how we can do this. Is getting some color blending going. This got added a version or two back ago, but if we make is it just a blend or is there a color blend? There's a color mapper. I think we want blend. We're gonna start with blend. So this can just come after everything else. So this, immediately you see all of these colors start blending. So this is pretty straightforward. We have a what do we got? We got a strength and a radius. So these are very quickly sharing half their color with their neighbors, with a not overly large radius. It's how far they're supposed to be pushing apart from each other. But I could calm this down a little bit. So if we say 25%, it'll take twice as long, a little bit more. But you see that these colors, as they intermingle, are going to start kind of blurring and blending between each other. So I don't know to what degree these will actually be able to maintain their colors through all this churn. I'm going to pull everything back just to get it going a little bit quicker. But as they go through, the colors get like intermingled, but this blending is going to make those colors start to blur on each other, so they become a little bit more uniform. And eventually we're going to get a very uniform kind of sludge color, and we're going to see like, kind of what the winner is here. Eventually, we see we're ending in this kind of like warm pink area. Now, as different colors come through, they might change more, but you see they're all blending a little bit. So, that's kind of one thing. It's kind of fun to change those colors. I don't know how well this feedback loop will go, but there's something you can do now where if we take a color mapper, you can take its properties. So currently we're looking at the color, and here's the property that's important is we've got this mix property. Currently we are 100% taking the age of the particle and recolorizing it. But I'm going to say, give me the color of the particle. And actually, it's RGB. I think we might have to, I think we have to get not the age, and we can't get the color because we only get RGB. Instead, we'll do the field. So we're going to take the field, and we're going to say, give me the particle color. So this is now, what's a good way of showing this? Essentially, this should be doing nothing right now. This is saying, hey, change the color. Change the color to what? Well, change the color to the current color of the particle, which means it doesn't change. So these are still blending, and they're doing their own thing. But let me show you. Now that we're in this field, using this color mapper, I could do something like make a solid and set that to normal and set this to some color. So let's say it's green. So you see the whole thing just turns green, but they added in this mix property, and I love the mix property. So let's say it's actually 2%. So now what's going to happen is, oh, well, now they're still just turning green, but here's, I think if I grab this and I start pulling down on the opacity, does the mix even matter? I don't think the mix matters in this. Yeah, I'll leave it at 100% mix. But because we have fields here, you can see that every single frame, it is saying, well, take whatever the color of the particle is, add 7% green, and then that's the color. But next frame, it's already 7% green, so the next frame becomes more green. So whatever percentage I set this down to, we can actually start slowly infecting. We'll start over again. You see that they're all their color, but slowly over time, they're turning more and more green. So they're just going to fade in that color. Now, what's cool is this is fields, obviously, so they're all slowly turning green, but I could make a spherical field. And let's scoot that forward. And let's go to this choke point, actually. Shrink that down. And we'll say, hey, as you go through our lovely little choke point inside our color mapper, don't go to max. We'll set that to normal, color remap. And yeah, well, right now it's pink. So you see that they're going to go through. And as soon as they hit this choke point, they're going to turn green. So this is a way of us changing the colors just based on fields. But the thing that the thing I wanted to show off is if you have the Rocket Lasso field pack that we made. So it's one of the plugins that we made. It goes with our field driver, but you can get the fields as a standalone. And you'll see that one of our fields is actually the Rocket hue, saturation, and brightness. So just like, in like paint applications, you can modify the color. So like right now I could say, hey, just shift the hue. So I can just grab all of these and say shift the hue, but this is a feedback loop. So we could right now. Okay. So let me slow down a little bit. So if we just restart this, what's currently happening? Well, I'm not changing the color. I'm not changing the spherical field. We're not doing any of that stuff. But right now they are still blending, and that's because of the color blend that we're doing. So that means they're all slowly essentially losing their saturation a little bit because they're all blending with neighboring colors. But if we take the hue, saturation, and brightness from Rocket Lasso and we say, actually, take whatever color you currently are and slightly increase your saturation, then they're kind of crossfading. But now we're saying, yeah, but whatever your color is, make it brighter. And as this runs through, you see that they become very, very, very saturated. Now you might eventually lose some of the colors. We might lose the pure neon because they're going to get to these very, very saturated versions of their colors. But you can see now that they're not turning into that faded out gray. I'm just doing a 1% additional saturation every frame, and you can see that we're getting this super duper saturated version of the color. If we turn off this color mapper, if we turn off the Rocket Lasso hue, saturation, and brightness, you'll see as these flow through, we're losing color. You see how gray those have become, and they're all becoming more uniform. So doing a very subtle feedback loop by saying like, oh, slightly increase the saturation, then all this little gray, and it's gone far enough. You see all like kind of the fading out. We got bright colors here. They're fading out over there. Now let's say, let's start cranking up the saturation. Even here, we should see them start slowly brightening up a little bit. And yeah, look how purple those became and how orange. So like the saturation starts coming back again. And then we can do something like grab the hue, and I'm going to say, okay, start shifting your hue at 1% as well. And so now they're taking their current color and then becoming kind of circling around the rainbow. And you see now they're slowly transitioning through the colors as a feedback loop just within the particles themselves. So yeah, pretty fun to be able to, put these feedback loops through the entire system as well. I dig it. Let's see. Demi is asking, is it possible to colorize the density of the particles? Like those particles you made. Yeah. Essentially colorize it depending on the density. Didn't we? I thought we had a question like this last season where I did figure out a rig to do that. But how did I do that? Let's delete those out. We're just back to this rig because already this rig is going to increase our density for us. So density. I'm going to make a color mapper. Field, drag in the particle. What options do we get here? Okay, we do get average. But density. See, right now, there's no density parameter. There's nothing that informs us of this. But we do have things like the flocking. And the flocking has an output particle. Yeah, okay. Neighbor count. So this is new. This is new stuff in cinema. And I feel like there might be a way of kind of getting this regardless, like in a different way. But we could potentially try and use a new custom data. So this, we can say the flock is doing a whole lot of calculation. So what Maxon did is they made it so that it can output some bits of additional information for us. So here, one of them is any given particle knows how many neighbors it has, presumably within its largest current radius. So the three radii are the cohesion radius, separation radius, and the velocity alignment radius. So whichever one of those is biggest, it's kind of like, oh, well, it has to do a calculation of everything that's within that range. So I'm assuming that this is now saying, because this is our largest radius of 10, it's saying how many particles am I close to? How many particles are within 10 of me? And that will output a custom number that's going to output, I don't know how many particles might get in range, but it's going to be anywhere from 0 to, well, if we cram them in real tight, who knows, infinity. But given the scene as we have it, maybe it'll say up to 6 or something like that. So just by saying neighbor count, we now have a type of data that we can access. So now we can do something like grab the color mapper, and we're going to say we want to work from a property. Well, what property do we want to be affecting? And the property we want is a custom one. So let's click on custom property. What property do we want? Well, if we click on this little drop down, you can see there's neighbor count because we activated it. We could rename it whatever we want, but now I can say, give me the neighbor count. And it's going from 0 to 100, but I'm going to say, give me from 0 to 10. And let's load in a rainbow so we get like this real broad spectrum. And as soon as we go even a frame forward, everything should get colorized. And look at that. There we go. So simple as that. There's our density. So you can see here that, and I'm guessing from 0 to 10, which actually seems pretty close. You can see that some of them are purple, which means they have no neighbor. And some of them are red, which means they have 10 neighbors. And they're getting colorized by that. So now let's go and load in just a simple black to white gradient, and I'll invert that. So now you see the particles are getting darker when there's like 10 particles crammed up on top of each other. So yeah, as simple as that. And that is one of those custom properties. And we essentially there's only episode 4 of the season, but we haven't gotten too many particle questions yet. But I think there is so much power, and we're gonna be able to do so much cool stuff as we play with these custom properties, because even with some of the little tests I've done, like we can go crazy with this because we've got all this data and we can remap data and take one bit of data and send it somewhere else. And there's even like a custom capsule that you can like just do raw math on all of this stuff and remap data like in crazy ways. So yeah, I'm really excited for some of the possibilities that we're going to get there. And even right now, it's like, well, we just happen to be using a flock, but we could make a flock. We could make a large radius and just pretty much say, like, there's no power behind it, but here's a radius. So we could increase the radius and get additional information. We could remap this. Like right now, I think over here, maybe these are even getting higher than 10. You see it's very dark. So we could say, okay, well, actually, this probably is going up to like, I don't know, 25. And yeah, here you can see that when I said 25, that's super dense still. It's really dark. Now, of course, I often reach for this rainbow because the rainbow is giving us like kind of visually the most feedback we could want, that we're actually seeing this, all this different density. But now early on, you see that these are not getting very dense as compared to this choke point, which is not surprising. This is where it gets the thinnest. So now suddenly the most particles are cramming up on top of each other. And even here, you see that we are getting all the way up to red. So I imagine like somewhere around 30. Yeah, if I say 35, that's too much. Actually, no, even at 35, we are still getting a couple of reds there. But of course, this is a visual thing, and we'd have to like remap these numbers. But yeah, now we actually have this full range. Now, based on that range, maybe we do still want things darker, but at least we know. I just used this rainbow to calibrate it a little bit better, given these settings. If I said create more particles, if we say flow slower, if we add more friction, any of these could dramatically change the count. But yeah, this gave us nice visual feedback. We get all this beautiful density information, and that density information could do a lot. Like think about if we were making some sort of geometry here, we could be using this to like make foam. So actually, yeah, let's make a gradient here. I'll go back to let's grab the sky gradient because that's getting us a lot of the way there. Let's invert that. And I'm just going to simplify distribute knots. And yeah, look, now we can kind of get like some little foam. Like we know where to put foam because that's where all the density is kind of like churned up. Of course, we could also map the speed on here, but like those aren't moving fast. They're just really dense. But yeah, there we are getting some colors based on how dense it is. Yeah, it's pretty cool. I had no idea how to do that when we started. We just lucked out that that custom density was there, and that I know just enough about the custom density to actually know where to look. But yeah, it's pretty cool. And we could be mapping this information. We could be layering up so much different information as well. Mapping, we could be like, oh, it's how dense it is times how fast it's moving. or how old the particle is. Like all this information could be combined and built into more complex rigs. And actually, you can see here when the emitter is first going, it's actually extra dense, and then they spread apart before we get the first strike here. And just because it's a gradient, I could remap this to be like, okay, let's I want more churn going, so we can like crank this up a little bit, but we still get our full spectrum going. So just something like that. Like, so here we're not doing that much with it. It's a very simple gradient now, but we had all that complex information that we visualized, and now we're able to make it, look exactly how we want. And then even here, we could potentially, maybe it's not a good idea. I'm trying to think of how hard it would be. Maybe it wouldn't be as easy. I was trying to think if there's a way, or a simple way, maybe, that we could make these colors fade. Or it's like once they turn light, that's like, oh, they're kind of like all foamy, and it take a little extra time for them to defoam. But that would be adding in like a time variable here. There's no time variable given the rig as we have it. A field might be able to do it via some sort of fade, maybe. Now I really like where we got this one, so I'm going to save that. Yeah, really, really fun. I'm just curious if we made another, would it be a data mapper? I don't know if the color mapper will be able to see this. So this might not work. But if we go to fields, we drag in the particle color themselves, that should be directly taking out the color of the particle, 100% getting applied. And then if we make a delay, the values go up higher. I'm gonna make it really high. Either, I guess that's the rig. Either that works or it doesn't. So this is pretty much saying, like, if it gets brighter, it wants to stay bright for a long time. And I made that number quite high, so I'll drop it down a little bit. So when this gets all choked up here, and they do get bright, gotta give it a second for the particles to gather. Will they? Oh, I think they will. Yeah. Okay, that was simple. So yeah, another color mapper used the data, made a little feedback loop here, and this is just this field list is just in color mode, is just dealing with color, and delay and decay can see color. So pretty much I'm saying if it's a brighter pixel, it's going to take a while to fade down to whatever the darker version of it is. So now you can see that turning on this color mapper, you see as soon as I turn it off, now the colors, as soon as the density goes down, they fade back out. This layer is now saying, once I've gotten really bright, I want to take a while before I fade back out again. And we make that number whatever we like. Even here, that's taking a while for them to fade. So we could, drop this down to 90. And now they're losing like 10% of their brightness every frame. So now, yeah, by the time it gets to about here, you see it completely fade out. But now it lasts a little bit through there. That was interesting. Or it looked like there was some sort of refresh something there. But yeah, oh, pretty cool. Pretty cool. I like it. Oh, dang. I was going to say we probably have time to squeeze one more fast one in, but I just tinkered right through it. Would you like to make a benchmark between Redshift and Pyrocluster? Oh, I haven't rendered a Pyrocluster in forever. I mean, because Pyrocluster is only going to render in like physical, right? I mean, this isn't even going to be a contest. Redshift is quite fast at rendering out a volumetric. Yeah, Phil, I agree. Phil's saying that the custom data is kind of like in Houdini, and hopes that Maxon continues fleshing it out. And I totally agree. I love all the data mapping that we can do, and there's a lot of it, like a lot of different settings. Like if we go to predator prey, you see in the output that we also have, we can find out how many predator neighbors there are, how many prey neighbors there are, if the predator is chasing, if like what particle the predator is changing, how far away the prey is, if it does catch its prey, Like, is the prey it's chasing fleeing? Or is the prey currently like, oh, look at all this information that we're getting from predator prey. So it's the type of thing that we could build. When I had my intern over here and I was giving him a demo of this new particle stuff, and I started building out like this whole rig where essentially the basic idea was like, oh, there's some particles are hunting other particles, and we gave them hit points. So it's like there was a hunter particle and it was constantly trying to target one. It was firing particles, it was firing bullets, and if the bullets hit a particle, that particle would lose hit points, a custom data. And but this type of thing goes to, it would all be like abstractly represented by particles, but it's the type of thing where we could be like, oh yeah, a particle, like if a particle is scared, it should move towards the nearest of this type of particle, and that type of particle we're calling a car. And once that particle gets to the car, that particle disappears, but now the car is considered on, and now that the car is on, that particle can now move 10 times faster. And then once its fuel runs out, then the car will stop and it will spit out another particle, which is the prey, and that one will run away, and it's going to run towards hit points because its hit points are not maximum, or it's going to heal over time. Like, these are all behaviors that we can build in now. Like, any story, any behavior you want to do, we can now represent abstractly with particles. And of course, those particles you could then be like, okay, well, I'm going to clone a car onto all the car particles. So, we could say like, oh, like there's a burning building and the particles are spreading from building to building. And once there's a certain number of particles, then the fire helicopter flies in and it spawns a particle, and that particle will try and go to where the fire is most dense. And then it's going to start spitting out more particles, and that's a spray of water. And when the water strikes the fire goes out. Like, these are all like any behavior, like almost any story you can think of, any action scene, we could abstractly represent with particles now, and then build those behaviors in, like in the simplest form or in incredibly complex forms. And it's all just inside the particle system now. So anyway, keep that in mind for not next week, because I'm not around next week. I'm on vacation. But the week after, maybe. Actually, the week after. Actually, I don't know if you're still here, Winbush, but we were saying earlier in the stream that I want you to be my first guest for this season. So I don't know if we want to squeeze it in for not next week, but the week after, but soon. So you and I should talk. Anyway, yeah, that is officially time. Thank you so much, everybody, for coming and hanging out as always. Let me grab this other mouse, go to the other computer, click some different buttons, and just say, yeah, thank you so much, everybody. I'm going to be immediately putting these scene files together and getting them up on Patreon. So you should see that within like 2 hours or so. Your support on Patreon is helping me be able to do these types of live streams. Because otherwise, as I mentioned last week, most of, this ends up eating most of the day, like setting up the live stream, getting all the graphics ready, getting the computer ready, getting everything exported, edited, uploaded, so this is me, giving up a lot of my free time. So support on Patreon is always super appreciated. And of course, you get all sorts of discounts on the plugins if you're supporting over there. So that's always super appreciated. Make sure you go and join the Slack channel as well. If you just head on over to rocketlasso.com and go to community, and you'll be able to get a link to the Slack channel to continue the conversations over there. I have no idea if Maxon will do a sale. But anyway, that should wrap this all up. I think it's just time to say thanks, everybody, and I'll see you in 2 weeks. Bye-bye.